All right, this is section 4.2. We're going to go through the learn and do an overview. The objectives here, we're going to calculate the correlation coefficient. We're going to calculate the linear regression line for a set of data. We're going to determine linear functions for given graphs. We're going to determine linear functions when given attributes. And then we're going to graph linear functions. So the biggest part of this are the second or the third, fourth, fifth points. Really the third and fourth. We're going to be determining linear functions for given graphs, and then we're going to determine linear functions when given attributes. We're going to spend a lot of time with that. These first two are very, very complicated, very tedious tasks to do by hand. So I will be showing you how to do that with the calculator. I've never done this by hand, not to say that it can't be done, but I was taught with technology, and so that's how I'm going to teach it. So you will need to go through the getting started videos if you haven't, and do the TI-84 calculator download. You will need that calculator or a similar calculator. There may be another way to do this by hand, but I don't know it. So I'll show you the way that I know, and then if you are unable to do it that way, then you will probably need to spend a lot of time working on doing it by hand, as you will see. So on the first page, we're given linear function here in this gray box. It just tells you the basic description and characteristics of a linear equation. It has a first degree polynomial, meaning usually you might see y equals mx plus b. This is what we call standard form of a linear equation, but now we have it in function notation. So f of x is the same as y. So note and be careful. So here it is down here with the y equals mx plus b form. Linear equation, both your variables, which are y and x, will be to the first degree, meaning they don't have an exponent. There's not a second power, third power. M and B will be numbers. They note and tell you what the y-intercept is. So the x value is 0, and then you get a number. That is known as the y-intercept, where the graph crosses the y-axis, and m is the slope, which they describe all that here. So you do want to be familiar. So here's some just examples of linear functions. They give you a set of ordered pairs. They show you those ordered pairs plotted and then a line drawn through them. If you're going to graph this by hand, you're going to start with the y-intercept at the back. So the 5, the 0, 5, you would plot that first, and then you would use your slope, rise over run. So it has -3. I would go down 3 and then right 1, down 3, right 1. If you're going the opposite direction, you would go up 3, left 1. Okay, so that's how you would graph a linear equation given the equation in slope-intercept form. So here's some more that show you what technology, show you what a constant function is, and I do need to be mindful to add those parent functions into the video section, which I will go do that. I will add it in content. I'll add it here in module 2, and I'll just add it down here. So shortly or later this week, you'll see some graphic PDFs that you can download and get the image of all the parent functions. But for right now, we're going to be mainly dealing with linear. Here's an example of them just kind of going over slope formula. Okay, so linear regression. This is something that I learned, I think it was in statistics, or actually a linear regression class in upper level math classes in college. So these are like sophomore, junior level classes. The first time I was introduced to this. I'm not really sure why it's a skill that they're adding to college algebra, but it is now. So let's go through it. You'll be given a set of ordered pairs. It'll be a scatter plot. Here they are. you can graph them, and then there are lines that we can try to draw that would fit the data. Okay, the line of best fit is going to be the one that's going to go through the center or the centermost points, as close to as many points as possible. So you see this line C doesn't really fit the trend, and this line A goes in the same direction, but it doesn't go through any of the points. So same direction, but not through. So this green line is the line of best fit. And again, I'm going to compute all of this with the calculator. Here is some of the process of finding and calculating regression line and the correlation coefficient, which both of those are going to be computed. You're going to take that set of ordered pairs right here. You have X values and you have Y values. So what they're doing, they're adding them all together and getting an average for the X values and the Y values. Then what they do is they use that average, and they're going to take each individual point and subtract the average from it. So 1 minus the 10 is giving them 9. The 0.3 minus the 10 is giving them the 7. So forth and so on. They do the same thing with Y, and you have another table of differences. So this little triangle symbol is what we call delta, Greek letter delta. It means change, the difference. So that tells you to subtract and get the difference. So the change in X is the difference in the X value and in the average that you computed. So once you do all those differences, and there are numerous opportunities to make mistakes. That's why we're going to do this with technology. You get all these differences, and then you're going to be multiplying those differences and adding them up. So this is the Greek letter sigma. It means to sum all these up. So what they're doing is they're going to multiply this number and that number and get an answer, and then you're going to add it to this number times this number and add that to this number times this number, and it goes all the way down the table. So they're showing you that here. Here's the difference in X, the difference in Y. If you multiply 9 and 10, you get about 90, but we have these decimals, so you get this number. So they multiply all those differences together all the way down, and here's that table. And then when you add all of these numbers up in this column, you get this sum. And then they do the same thing with just the X differences. They square them though. So they take this number and square it. And then they add up all of those, and you get the sum of delta X squared. All right, and then they take those two numbers and divide them, and then they get this. This number, as they're showing you here, is, let me look, because I haven't done this by hand. B, so they're solving for B, Y bar. So the average of Y minus M times the average of X is equal to 24. And where's this 24 coming from? I don't even know where this 24 is coming from. Where's the 24 come from? That's the slope. (24) is Y bar. Okay, that's the Y bar. Sorry, that's what's confused me. 24 is the Y bar. That's the Y average that we got. Up here, that's the Y average. So that's what this formula is. I'm sorry. That Y average minus M times X bar. So this is the slope that we get. So that M, that number right there, that 0.920, that is this number. They just use the whole thing. So they're using it in the slope Y equals MX plus B form to figure out B. And then that's how they get B. And so this is just to say it's really complicated. So I try to explain it. I'm sure that it's very confusing even with the explanation. So I will be showing you how to do this with a calculator. Then it gets even more complicated when you try to do the correlation coefficient. So this correlation coefficient just tells you the strength, like how strong the line is that you've plotted as far as being a good fit. It also gives you the direction. So if this number is positive, it tells you that your line will be going in the upward direction, okay? And then if it's close to 1, it tells you it's a really strong. So it'd be like a 0.9, 0.8. Means it's a really strong correlation. Okay, it means your model is good. However, if it is close to 0, like 0.12, 0.13, means it's really a weak model, but it will still give you, a correlation. So that's what R is. It's telling you how good the line is. It will be between 1 and -1. So if it's close to -1, that just means it's a strong negative relationship. And if it's close to +1, it's a strong positive relationship. And let me try to explain that real quick. So if you have a strong positive relationship, that means as one number increases, the other number increases, and that model does a good job of predicting. For example, if you work more hours at your job, then you should get more money on your paycheck. So as your hours go up, your pay goes up. Now, a negative relationship would be, let's talk about the amount of gas you have in your car. The more you drive, so as 1 goes up, the miles driven goes up, the amount of gas in the tank goes down. So that would be a negative relationship. One value increases, the other one decreases. So here are all the symbols, which are, again, quite confusing, but they explain it, or they do the best they can. It's hard to understand it unless you already know what's going on. So don't try to understand all this. Just see the videos and you'll see it from the example. There's probably about 4 or 5 that we do regarding this. So here again, just some more examples. They give you a scatter plot, give you some points. They're showing you the calculation, going through the table, and it is a lot. So I don't recommend doing it by hand. We're going to do it with technology. And then here's another example, going through it again and again. We're going to do it with technology. Should be really, really easy compared to what we're seeing here. And then here is a little bit of them explaining how to do it with the 84, but I'm going to do it and so you get some live video, because it's not always easy to go through and follow all of these steps. So I think that's it. We're going to jump over to Hawks and do some examples.